This is an aerial photogrammetry model of a crash in November of 2015. The vehicle was located in a swamp area off the highway here. The crash began when the vehicle left the road surface about 500 feet earlier or prior. Here's where the first tire mark, and here's where the second tire leaves the pavement. And because this is a photogrammetry model, we're able to determine the X, Y, and Z positions of all points anywhere you can see. So if you look down here in the right corner, you'll see that we have an X, Y, and Z offset from the origin, which is back closer to the vehicle. And you can see as I roll around, you can get very precise measurements. Another advantage of photogrammetry models is that you can view the incident from different perspectives. So it's a little bit difficult to see tire marks and treads and vehicle path, but if you change the perspective, it becomes much more clear how the vehicle left the road surface and traversed along the drainage area here. You can see that the vehicle traveled along the swale and then hit this driveway embankment area, took to the air, and then landed over here. The model is constructed from approximately 300 photographs taken by a drone. And I'll turn on the camera views. And you can now see where the drone was positioned at the time it took pictures over the area. So this upper level is a 100-foot elevation. And then the primary survey elevation is 50 foot. And then we did take a few 25-foot elevation flights for a little bit more visual detail around the vehicle. Photogrammetry software then combines all that information to create a three-dimensional understanding of the underlying space. To further document a crash scene, we can record points on the scene as you might do with a total station or other on-scene measurement techniques. So if I wanted to record the path of the left tire of the vehicle, I can simply click along the tire paths, and if I want to get more precise, I can zoom in. See some more tire marks here. Now with this line, I can export this as a tabled XYZ point list as an offset from the origin. We can also export that as a DXF file for importation into AutoCAD, CrashZone, some other crash investigation software. Using this approach, we can save up to hours of time spent on scene doing local measurements and still preserve all the information necessary to accurately document the crash and support reconstruction activities.